Thanks, Vakas, for coming over. And pleasure to have you
My
around.
pleasure.
And it'll be great, like, to hear from someone who is really hands-on and who is doing this RAG and other stuff on a daily basis, real person on ground. So,
Mhm.
floor is all yours. Today's topic is about RAG versus and inclusion of VectorDB.
First of all, thank you very much, Sai, for inviting me um, to your podcast. It's really interesting. You had a book. I read your book. That was amazing. And now you have this meeting with podcast going on. A lot of really good people are coming on, sharing their thoughts on what's happening in the field. It's always good to be part of this. Um, um, we can talk about RAG, but what I would suggest is maybe I will share my screen if you don't mind, because other than the slides, I have a few demos. So maybe we can
Okay.
make this session a little bit more interactive. I
Okay.
can show you RAG in real life, how it would look like, what people expect from RAG, how it really works, um, and then we can switch back to the slides. So I I'll share the slides also, and then we'll also share the other demos. Yeah, so today we basically wanted to talk about RAG, what RAG is. It's a buzzword that we keep hearing everywhere. Everyone's talking about Gen AI. And when Gen AI is being implemented within an enterprise, what we are hearing and seeing is one of the ways of implementing it is through this RAG method. Um, and the other buzzword that we always hear is this vector database. Right? So vector
Yes.
databases are also very popular nowadays.
Absolutely. I will be
And
throwing some tough questions on the way to you as well, because RAG is not dependent on vector. We all know that, right? But
yes,
vector is something which will really precise and give you more accurate results. So everybody want to go on to vector, but what are
yes.
the pros and cons? How costing works? All these questions I will throw you later.
So RAG is retrieval augmented generation. And what do we mean by RAG or retrieval augmented generation is we know that LLMs are smart. We have all used ChatGPT, Gemini, Claude, and all these tools. And when we are asking them questions, they are giving us back some responses, which are really good responses. The only problem with that is that these are very generic responses. So you have to really tell them your context. And then you will reach a point where, okay, they would know you a lot more because you have given them this context. And now they can answer your questions based on the context that you have provided. In an enterprise, this is very crucial because when you are doing work, you don't want general answers. What you really want is answers which are very specific to the knowledge base of that specific enterprise or that your workspace. So therefore, context have to be always available to these models. So that's the whole idea. If
Hmm.
we can provide more information to these models, they can then answer us much better. Not general, but they can then tell us, for example, the policies which are implemented within our enterprise. How do they know all of this? Just because we have provided them this. So this is the whole idea of why RAG is so popular in an enterprise. And like you mentioned, one of the way could be providing this knowledge to these LLMs, could be through some kind of persistent storage. And that storage could be in the form of vector, or it could be a SQL database, or it could be your analytics database like Snowflake, any data warehouse. It could be also in the form of APIs. So maybe some of the information is hidden behind a backend API. And then when you're asking this information, we have to make an API call and fetch that information. So that also could be a form of knowledge that is related to your enterprise, and that is not really in a database, but that's hidden behind an API. So it could be anything. But the whole point of this RAG is that we are providing this extra information that contains the answer to our question to the LLM before the LLM can provide us the answer. So here, what we are doing is we are just asking the LLM, hey, here is the question. Here is the information that we have within our enterprise. Take this question, take this relevant information, write a very, write a very good answer based on this information that I'm providing you, send it back to you. So the LLMs are not really, not really, they don't really contain all of this information. We are providing on the fly. As someone asks a question, we retrieve the context, we give the question and the context to the LLM. Now LLM have the question as well as the answer, and they are able to write the context, and now they are able to write the answers really well. So we can think of it like, a really smart guy, but every time you ask him a question, he's able to Google the answers, and now he's able to answer you. Think of it like that. He's
Smart.
not really a doctor, right? So he's able to Google it. He now have that information. He knows your question. He's generating the answers now. This is generally what is happening.
Okay.
The other thing that, but again, every single time you have to provide that context to that LLM. Right? So we are assuming at this point in time that LLM doesn't really know your enterprise data. We are providing it, that we are generating it, and we know the question, we know where the information is available, where the answer may be available. We are giving all of this information to the LLM in the flash. This is general RAG. Right? What we can do is, the other way of looking at it could be, okay, every single time this guy is really smart, but he's always asking me for the information. I have to give him this information, then he is generating the answer. So maybe he's just a smart guy. He doesn't really know my domain. So the other way of working could be that we can take that LLM and then train that LLM, which is also called fine tuning. So we can fine tune that LLM on our data. And now you have a guy who has gone to a medical school, who has studied for 4 years. Now he's a doctor. So he doesn't need extra information because he has already gone through this information and he has ingested this information and he has become a smart doctor. So that is fine tuning. So you can fine tune the model. When you have fine tuned the model, now you don't have to provide this extra information every single time. So you ask the question directly to that LLM.
A question here. See, once you do fine tuning, what we are doing is we are training the model, right? And when we are training the model, what we are saying is we are giving them enough information so this model keep that in its own memory or some storage, read and put it over there, right? But then this question will come because, see, I'm taking it towards, of course, I should not take it toward the costing, but costing is something which people normally look into it for their ROI planning. So this tokens, right? If you throw as much data into LLM training, the token cost will go really high. So what is the best way to manage that? Because most of the places where I am seeing LLM or RAG, they don't train it. They chunk it, they put it, and on a random, the moment you start a chart, you start something, it goes and fetch the data, and they keep the history somewhere into RDBMS, and they refer that for the next question. But they're not training it. The people say, corporate world says, if you train it, it becomes so expensive that it's not worth doing it. What's your thought about that?
Yeah. I mean, it really depends upon what you are trying to achieve, what your use cases are, right? If your use cases are really huge, they're very general, a model is already trained in the form of GPT-4o, so you don't really need to retrain that general model. But if you are dealing with a very specific domain, let's say medical, and within medical, you are dealing with very specific area or a department, then it would be a good idea to train the model once. And now you don't have to send this extra information to the model again. You mentioned tokens, right? Tokens is this specific information. So let's just have a look at this one. Maybe I'll share with you this. Right? So what is happening in the RAG is, as you ask the question, we are sending your question in the form of a prompt, but also we are retrieving these information which could contain the answer to your question, right? So let's
Hmm.
say you have 200 PDFs. The answer is somewhere there in those PDFs. When you ask the question, we will fetch that information and then we will send it to the LLM. Now the LLM have your question and have all of those sources of the data, which means there's a lot of tokens now because these all are words.
Hmm.
And the more information you retrieve and the more you send to the LLM, these are all tokens and you'll be paying a lot more.
Yes.
Now imagine you would have trained this LLM once and your data doesn't change much. So the only thing that will be going to the question, the only thing that will be going to the LLM is going to be this question. So you would have spent a lot of money training this LLM, but now you don't have to send extra data to the LLM, right? Which means you will, instead of sending 1,000 tokens in every single call, now you will only be sending, let's say, 20 tokens every single time. But you have spent a lot of money training that LLM. So,
Hmm.
it really depends upon the use case, right? Which one do you really want to go?
That's
So
actually,
in RAG, what is happening?
this is a very good response, right? Because it's again a give and take. If your data
Exactly.
is very huge, it's better to train it one time. If your data is small and use case is
And it
small,
doesn't vary. And
yes.
it doesn't vary, for example,
Uh,
right? So because remember, I mean, if you studied once for a medical exam, the syllabus has changed after 10 years. And now your knowledge is obsolete or getting obsolete. So you now need to know, you need to have this new information. Here, you would always retrieve the latest information.
mm,
Here, once we have, you remember what happened when GPT-4 first came out? It had that cutoff limit. I can only answer questions before this. I cannot answer questions about recent events. Right?
mm,
How did we solve that? The way we solved it is, as you ask the question now, first we do a Google search and it retrieves all the latest information about the event that you have asked, sends it to GPT-4, and now it have the latest info, right? Again, all of this is right, except that it is making a Google search based on your question. So when I'm asking it, hey, what is the weather in Kuala Lumpur today? How come it is able to answer that? It is able to answer that because as it took my question, it did a Google search, it collected that information back, and then sent it to the LLM. It said, hey, here is a question. Here's the information I found on the internet. LLM, can you help me create the answer? And then you get an answer which looks
so
something
we are
like this.
referring, yeah, so we are referring to ChatGPT 4, right? Where we have a new data all the
I
time.
can, again, ChatGPT 4 still doesn't have this data, but what I'm trying to show you is 1 minute here, right? So I have certain documents. For example, in this demo, what you'll be able to see is when I'm asking questions in any language, again, these models are multilingual. So you can ask in Arabic, you can ask in Malay, you can ask in English.
Mm-hmm.
It comes back with a response. But here, so here it is telling me, hey, I got this answer from this specific document that you have given. Right? So it will open up that document telling me the response is coming from this specific document. The next question I asked is, what is the weather in Kuala Lumpur today? This time it is going and doing a search. It's coming back with a response, but obviously the search would have only given it this, but it have this response and it have my question, and the LLM is helping me to write an answer in natural language.
Mm.
Again, this information was important. If I would have trained a model only on the previous data, it wouldn't have this information with it
Mm.
because it was trained on the previous data. So it's not either or, it is both. You have to do fine tuning, but if your data keeps changing, you also have to provide the latest information to that model. Okay?
Mm.
I hope that makes sense.
No,
So
this is
we
perfect.
have,
Yeah, I was just
yeah,
looking towards the performance thing, right? When you keep training data, it takes time to train, right? So
yeah.
are we saying that overnight we must train just like traditional batch processing? Is that so? So this retrieve thing, yes, whatever we are taking from Google here, XYZ with APIs, REST APIs, yes, that can be very fast. But what about thousands of documents? Of course, everyday documents are not updating, but out of thousands of documents, 5% do change. Are we saying that we should overnight a daily batch we keep training our LLM? Is that you're referring? I think there's nothing wrong in it.
No, I mean, that's one way of looking at it. You might have to do it, every single day. Again, there are multiple models. What you are talking about is full model, right? That means every single day we have to retrain the model. But
Hmm.
what if you want real-time information? Like just now, I said, what is the weather like today, right?
Hmm.
So I need today's information. Probably the model is not really trained at this point in time, so I will not be able to fetch this information, right?
Hmm.
But training the model helps. You don't have to train it every single day. Like I said, if your use cases are real time or you want generally, nobody want to see old data. Everybody want to see real data, right? They want to see the latest file changes. They always want to get access to the latest data. In
Hmm.
those scenarios, RAG is the perfect solution because RAG will always get you information based on the latest changes that you have. We are not training the model. Here, all of the responses, like for example, here, what we are looking at when I ask it this question, or when I ask it what is a transaction management office, for example, this information came back from a document, right? This
Hmm.
document was there somewhere. It then got this information and brought it back.
Hmm.
If the document gets changed, when I ask the question, I will get the new information because I have changed this document. This information is contained by me, right? So I can change it very quickly and I will still be able to get the answers. Why? Because we are getting this on the fly as I ask the question and this information is retrieved back. And this is where vector stores comes in, right? They play a very crucial role in saving those information efficiently. Without vector stores, we will not be able to save these unstructured information. What do we mean by unstructured information? We mean that we have PDFs, we have PPTs, we have all of this information, and then we have saved it somewhere on a local storage, either in ADLS2 or somewhere in a data lake somewhere or a SharePoint folder, SharePoint list somewhere, and we want to ask questions against it.
Hmm.
This information is text, a lot of text. And if we go by traditional methods, we will have to make sure that we're asking the exact question. Only then we'll be able to do the keyword search, keyword match. Or we can try regex, for example, and then, but it is very difficult to capture these dynamic questions context in the form of a regex. So we need a new mechanism. What is that mechanism? You take that whole document. Right? So this is the ingestion pipeline. You have this whole document here. You just mentioned earlier about chunking. What do we mean by chunking is you take this one document, you break this document down into smaller pieces. You can break it down by paragraph, you can break it down by page, it could be any strategy that you are looking for. Right?
Hmm.
Once you break this down, you then convert each part of it into a vector, right? Or embedding.
Question.
Right?
A
These are some,
question.
yeah.
A question. When you're saying unstructured data, right? As I can see under your box of load, I do see images, I do see JSON, URL, PDF, all this stuff. Are we saying that when we use this embedding model or vector thinking, we don't need to convert unstructured into semi-structure? We can throw we can throw audios and videos and it can chunk the audio video itself like that, or we have to first convert it and then chunk it.
No, that's the beauty of these models, the embedding models, that they can even understand all kind of unstructured information.
Oh,
It
really?
depends upon different kind of embedding models. So there are embedding models which are specific to understanding images. So you can then push those. You can just embed that. Again, you can convert that image into an embedding. So you
Hmm.
need an embedding model that allows for that. But there are different embedding models that you can use. So just like you see, we have these earlier when we were using GPT-4, we could only send text. Now we have models which can also understand our images. So we can upload an image and they can understand what is happening in that image. Right?
So, okay. I want to spend a little bit more time on this piece because what you are saying here is, which is a big sharing by you, is we are saying that we might not need cognitive services to convert unstructured pieces into structure or text before we throw into vector. We don't need that. There are embedding models over there which can easily go and read the PDF, Word document, or PowerPoint. These are text oriented files, right? Word, PowerPoint, emails, PDF. These are text oriented files. So there are
Yeah,
embedding model open source which can read and convert it. And then for audio video, you are saying CCTV, which is again video. There are embedding
which
models.
is again frames. A video is nothing but 30 frames per
Yeah,
second. So again,
yes,
those are frames. Yeah.
yes. So embedding models can directly. Oh wow, this is good for this is good, Vikas. Okay, good. Okay.
Exactly. However, you also have to understand one thing is what is expected out of this. When you're embedding something, how will you be retrieving this information, right? So
Hmm.
let's say if the information that is being retrieved, on Google, there is a functionality on Google Lens app or on Google image search where you upload one image and it will find similar images, relevant images, and give you back all those images.
Hmm.
This is vector search or vector retrieval that we are doing with image. What
Okay.
we have done is we had an image, we embedded it, we uploaded it to Google, right? And now Google have embedded all of the images that it have in its repository, and it is able to find similar images like that. If your image had a cat, that information about cat in all of those images that Google have, it is able to pull similar images. It is doing vector match and showing you, cat images, for example.
Good. It
Right?
must be breaking because, as you correctly mentioned, a video is nothing more than frames. It converts frame
Yeah,
into different chunks and go each frame it go and search and matching frames from different images. It bring it and get the actual image and put it in front of you. Okay, that makes
yeah,
sense.
yeah,
Makes
yeah.
sense. Okay.
So again, but maybe here what we are trying to do is we are asking questions. So, if we say show me all images of cats, yes, then we could do this vector search against the images embedding, then we can pull back all the images of it, right? That could be done. But
Hmm.
if you want, more details out of it, so what you can do is you can take that image, send it to a vision model, or like you mentioned, cognitive services, ask it to explain it, what is going on in this image. And then you will get a big summary. And now you can chunk that and save it in the vector store,
Hmm.
right?
Hmm.
That is also something that you can do. So again, we can do a lot of things, but it really depends at the end of the day what the goal is, right? So we always have to go back and think about, okay, why are we doing this, and how will people be accessing this data? Sometimes you take this image and you do multiple embeddings of these, and then
Hmm.
you save it again in a vector store. All of this revolves around managing these vectors. Where do we manage these vectors? In a vector store. That's why in all of this, vector stores plays a very crucial role, because without vector stores, there's no real efficient way to manage all of this data and to do very quick retrieval. So again, vectors would look like this. Even if they were images, they would look like this. And
Hmm.
that really depends upon the embedding model. So one of the crucial role of coming up with these vectors is played by a model called an embedding model.
Hmm.
So
Hmm.
OpenAI, we know GPT-4, we know GPT 3.5, we know GPT 4o now, we know GPT 4o mini. In terms of cost, you are talking about is really efficient if you use GPT 4o mini. But there are other models which are embedding models by OpenAI, like ADA 002, 003 large. Their job is only to save embeddings or to convert text, videos, images into efficient embeddings. Once you have those embeddings, then you will save it in a vector store. Now you have a vector store. The
Hmm.
next time when someone asks a question, you will retrieve that information, right, in the
Hmm.
form of a RAG, and you will know, oh, okay, I now know that this information is somewhere in the vector store. You ask a question, what is the policy? What is the HR policy for this specific purpose? It will go and find the similar matches, bring you back all of this. You can then send it to the LLM, and you get a very nice document.
Okay, okay.
Example of this could be here. So this is our tool, built by my team last year. So when we are asking a question like what is the performance excellence program, for example, it is going in, fetching all of those relevant information. It found all of this information is actually mentioned in our IT handbook, which is for Ukraine, for example. Okay? And
Mm-hmm.
when I click on it, it is able to come back with the answer, and then I can see that specific file. Where is it coming? Right over here. Similar thing, right? Here it is showing me the whole file, but we have others where, let's say when I'm asking this a specific question, what is the transition management office? Same thing. As I asked it a question, the information is available in one of these documents. So I have hundreds of documents which are in the vector store, or they were in the SharePoint. I converted all of them in the form of vector. Now they are sitting in the vector store. When I asked this question, I did a retrieval search. So I found the best possible matches to transition management office from all of that huge vector store that I have. I probably got 3 or 5 responses that came back. I sent that to LLM, and now I'm getting this specific answer.
Mm-hmm.
Where is it coming from? It is coming from this specific page number 35 of this document, whatever that document is, right?
Mm-hmm.
Right, so yeah, here you see, it is going to supporting implementation through the TMS. Right? So now, imagine I had hundreds of documents, but now I just ask a question, and I don't really have to know where the document is sitting, who uploaded the document. I'm able to retrieve this information on the fly.
Question.
So this
Question.
is the yeah,
Question. See, when you're throwing this document into
yeah.
vector, what you're doing is first you're splitting it. So when you're splitting and putting into vector, are you sending top three chunks or you're sending everything into vector store?
What do you mean by top 3 chunks? See here, let me show you. What you're talking about is this. Let's have a look at this. So this is my ingestion pipeline.
Yes.
This is a one-time process, right?
Yes.
First time, when I uploaded the file,
Hmm.
I broke that file into chunks. So if there were 100 pages, I broke it into 100 chunks, for
Hmm.
example, right? So I have 100 chunks now. I
Hmm.
push them in the vector store.
Hmm.
All the 100
All
chunks are
chunks.
there in the vector store.
Oh,
Yes.
so what you're saying is you have.
Otherwise, I would have lost the information. There's no top 3 here. This is a file that I have.
Hmm.
Every page is important. Every chunk is important. It should go and sit in the vector store.
So are we saying that when it
Now,
makes a chunk, it is an obvious at back end, it must be managing metadata that which chunk is related to which chunk?
absolutely, absolutely. Which chunk is related to which file? Who
Hmm.
uploaded that file? What time it was uploaded, right? What kind of data it contains? Is it an image embedding? Is it so? Metadata plays a very crucial role, obviously. So what
Hmm.
you are talking about is with every single vector here, there is some metadata attached to it, of
Hmm.
course,
Hmm. Hmm.
for
Okay. And
sure. Right?
metadata is also part of the vector, or metadata we keep it somewhere in a database.
Which is a vector store. So right now we don't have, we can use a separate database to save all of this metadata, but vector store allows you to not only save vectors, but also save additional data fields in the form of metadata. So it all gets saved within vector store.
Oh, so in vector store we are keeping metadata as well as chunks and all those things.
Yep. Yeah.
And
If you want to see an example, let's have a look at it, right? So
yeah,
let's go and have a look at this example since you are interested in it.
actually
Let me go and show you how.
you have changed the whole horizon of learning which I've done in last few months. And that is not only Google Learning, that is from very big vendors and companies, and they talk shit about all this thing. That's why I love to talk to people like you who are on ground, who are really
Yeah.
working on it. Okay, that's good.
Yeah, let's go. Let me show you how how the metadata would look like. Good that you brought that up.
It seems,
Um,
meanwhile, you're searching this RG. See, what I
yeah,
was told that metadata as a structured data, kind of structure because
yeah,
file name, who
yeah,
created
yeah, yeah, yeah,
it's all structured
yeah.
data. You have to put it into some RDBMS, and and unstructured data will go to vector. Structure will not go to vector, but here you are saying structure will also go into vector.
Absolutely. It will go and I'll show you how would it look like. Right. So I'm here using Azure Search Service or Azure Cognitive Search, as you call
Okay.
it, right? ACS. We have multiple different databases or vector stores that we can use. But what I really want to show you is
Now you're
in this.
using
Let's
a
say,
ACS, old ACS index.
yeah, I'm using this ACS index. Do I have any? Uh, if I'm able to find some similar matches. Okay, here we go. Right. So this was the semantic search. We haven't yet touched what is the meaning of semantic search and keyword search yet. But what I really want to show is some of the fields that you will see over here is this embedding. So this is a field, right?
Mm-hmm.
This was the actual content of the
Mm-hmm.
chunk. This is the embedding. We did an embedding match. And
Mm-hmm.
now we also have where is this file located, for example. Where is this storage URL? What is the page number, for example? This
So
is what I mean by metadata.
yeah, so you are showing me the index, right?
I'm showing you the index. And when you ask a question about a chunk, what
Mm-hmm.
I'm showing you is this specific chunk was retrieved, right? We got this thing in the blue.
No, 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 pause, pause.
In this,
No, no, pause,
yeah,
pause. When you say showing me index, you are showing me this index data which you just shown me that was in vendor vector DB of index, is it?
yeah. So we have a vector DB.
Hmm.
Within that vector DB, we have an index or a collection, depending
Ah,
upon, different
okay,
vendors, what they would
okay,
call it.
okay.
Within that index, now you have those small chunks saved. This
Oh, okay,
is inside that index, right? What I did was I went to this vector store. I opened up one index where I have a lot of information.
okay.
When I asked a question, it gave me this. And
Got it,
I'm
got
showing
it.
you right now this
I
one
got it.
chunk.
I got
So
it.
the metadata is in the chunk,
Okay, got it,
right?
got it.
If
Now,
that is what you mean by metadata,
yeah,
right?
yeah, yeah, that is what
Yeah,
I mean. A question related, related
yeah,
question. See,
yeah.
when we think about vector DB, we think about it will convert into a binary format. But what you
Uh-huh.
showed me what was a JSON format. So are we saying there's a different vector DB with binary, or this is what we what is this? You go
Oh,
you
okay. So let's have a look at it. Again, this is an API, right? This is we are using Azure Search.
mm,
When you retrieve the information,
mm.
you get information back in this specific manner,
Oh, this is a
right? You get
format.
information.
The format.
Yep. Yeah, this is we are calling Azure Search API, probably Azure
Okay, okay,
Search
okay.
portal here. Would
Got
call
it.
an API and give us back this information.
But you were hitting a vector DB, right?
Yeah, yeah. This query again, if it was not VectorDB, I
Hmm.
wouldn't get back information like this, right? This is a semantic search which is happening on the
Hmm.
index, which is a vector index.
Awesome, awesome. By the way, just a time check. We have 15 minutes. I'm sure we need
Okay.
a follow-up session on it. So why I'm saying follow-up session? Because session is going very good. I don't want to rush into many other slides. I want to go, if you don't mind, of course. We can have follow-up
Yeah.
sessions on this because this is going very good. And I think whoever will be listening this will be really learning this how it goes. So we are saying this vector DB. So which vector DB you're using for this example?
For this example I just showed you, the VectorDB is this Azure Cognitive Search. Right?
Oh, so
So
it is
ACS.
vector DB,
Yes.
ACS vector DB.
Yes. Yes.
Yeah, yeah,
I'm
okay,
using the cognitive search, right? Azure
okay.
AI Search.
So
However, you have multiple
yeah,
different VectorDBs. I have a slide somewhere over here which yeah, here.
yeah.
So you see, I'm using Azure Cognitive Search because in enterprises, it's very common to use Azure native solution, and we are also Microsoft partners, so we really, emphasize on using this based on its performance. But you may even use Pinecone files, which is not a vector DB, but just an index,
Hmm,
right?
hmm,
So it doesn't have all of those capabilities
hmm,
of a vector DB. Like you can scale it, as much as you want, serverless, so on and so forth. But others here, Milvus, VB8, Cosmos DB from
hmm.
Azure, and then MongoDB, Atlas, also now have the capability of saving the data in the form of vectors. And then Postgres have an extension called PG Vector. So
Oh,
for a lot of the deployments where it is important to host your vector database on-prem, we use PG Vector, right? Because it is very native to Postgres. If Postgres is a qualified resource for
hmm.
your organization, then it's best to use PG Vector. And now you have within that Postgres server, you now have the capability to manage vector stores or vector data with the help of this PG.
Question for our audience. When we keep talking about VectorDB, we are saying at backend VectorDB, keep it in a binary format, right?
Um, what do you mean by binary format? And what kind of data you are talking about? Are you talking about vectors,
Vectors,
specific
yeah.
vectors?
Yeah. So
Yeah.
when
So
hmm,
vectors will be stored just like this. Again, let's go back. Right. We have an index. Right.
hmm,
In this index, I have all of those chunks that we saw earlier. Right.
hmm, hmm.
So here, when I'm asking it, for example, what is transition? I'm not sure what documents do I have here. Uh, let's just say. So it will find some matches. Right? It found multiple matches. So
I
here I got the
agree with
first.
you.
Yeah.
But question is where
Here
it
we
is.
have.
No, the
Yeah.
question
Here
is
we have this information, which
okay.
is the actual information,
Mm-hmm.
but the binary data is here, which is the embedding, the vectors
So
that we
it
were
is in
talking about.
format.
This is where we have it. Yeah.
It is in binary format sitting backend somewhere. Because see, because when so do you have indexers? You don't have indexes, right? You only directly use index, correct?
Um, okay. So I think you're coming from the traditional
Yeah. Because
OLTP
I want
databases and you're talking about indexes, right?
correct.
This is the index that we have here. Yeah.
No, okay. Let me explain myself. Because previous, see, vector just came into picture like a year back. Before that, vectors were not in the picture. RAG were still there, especially in Azure, because I also worked in Azure. So in the Azure ACS, now which they call it search, AI search, they had indexers. They have structured indexers, they have unstructured indexers, they have
Yep.
NER indexers.
Yep.
So
Yeah.
indexer,
Here we are talking about this specific indexer
yes.
here. Yep.
So when you write an indexer, in the indexer,
Uh-huh.
you answered me that you don't have an indexer. So previously, what you we were doing is in indexer, we say this is the files. We read that file, there's a mapping under it, and it writes into an index, or it can
Yep.
write into a storage as well, which can be in a JSON format or XYZ format.
Yep.
So here
Yep.
what we are
Yep.
saying, you are not using indexer, you already answered me. So you must be writing a pipeline or somewhere, which I will ask you. You read from the source as an input and you directly split it and then you do embedding and then you write into the index. And this index is nothing more than a vector DB at backend, correct?
Yep. Absolutely.
Okay, awesome.
Absolutely.
Awesome. I'm with you now. I'm with you now. So there is
Yeah.
no indexers. Okay.
It can be. I mean, there can be.
Can
There's
be.
nothing wrong with it. You
Nothing wrong
see,
with it, yeah.
it really depends upon the use case.
Hmm.
Indexes work really well when it's a pull model. So let's say every day at 12 a.m., I now want to pull the data from those data sources and
Hmm.
then index them and then push them to this index, right?
Hmm.
Works really well. But what if I have latest data and I want it available at that point in time, right? Am I going to run the indexer again and again and again? We what we are talking about is real time updates to that database or to the vector store. So I am working on a push model, right? In this specific project that you are looking at, that means I don't need to have this indexer. I have my own indexer in the form of an event-driven architecture. As something happens, I invoke this indexer, the custom indexer that I have built, and it will then push the data into this vector DB. Right?
Got it, got it. So as again, we have a time check of 9 minutes. I don't want to go into next your slide, but I will keep ourselves over here. Let's explore
Yeah,
how you are doing this push mechanism based on the event base. Because if you go to other
yeah,
slides, you won't be able to finish it. So now my
yeah.
obvious question is, as you said, it's a push method or event-based method for a real time. How you run this orchestration?
Perfect. Okay, so let's first set the stage.
Hmm.
Let's say your documents are in SharePoint, okay?
Yep. Yeah.
And you went ahead and you added a new document in SharePoint,
Correct.
right? So it's a SharePoint folder. We now need to know that something has changed in the SharePoint folder. A
Correct.
new file has just arrived.
Correct.
At this point in time, there may be multiple mechanisms, but what we do is we have a logic app that is always, if anything changed there, we catch that trigger, the SharePoint trigger, and that invokes a logic app. Or it could have been any API. So we catch that event and then we invoke a certain trigger.
Okay.
That trigger will tell us something has changed in the SharePoint folder.
Actually,
We
share
pick that change.
actually SharePoint also give you APIs which can tell you
Exactly.
what are changes in SharePoint happens.
Exactly.
Yes.
Exactly. So that is an event, right? You put it
Mhm.
something there. It's a webhook. That means that somebody will notify you, hey, something has changed. There's a new file that came in the SharePoint, right? No
Mhm.
matter which way you want to capture that event. But now you have caught that event. Once you have that event, in this specific scenario, let's say the pipeline is you take something from SharePoint, you then
Mhm.
put it on blob storage, right?
Okay. You
Because
block.
that may be your ADLS, that may be your data lake. So you pick up that new file and you push it to your data lake, right?
Mhm. Mhm.
Once it reaches your data lake,
Mhm.
again, the same kind of mechanism would work. Blob storage or containers would also run an event and they will say, hey, there's a new file that just reached to me, or a file has been changed, for example,
Mhm.
right?
Fair enough.
Whatever. You,
Yeah.
you capture that event
Mhm.
and now you know that there's a new file which have to be opened up. We have
Mhm.
to create chunks. We have to do embeddings and now we have to push them to the index, right? That
In
is what we do.
VectorDB. So again, it's a event base, but it is not based on the real-time query. It's based on the event happened at source system that something has changed. So you have to bring it in. Correct?
Yeah, because the change is only happening on the original file,
Yes.
right?
So your front end doesn't know what.
Where no,
Hmm.
the front end doesn't need to know because the person who is asking the question doesn't need to know when the information changed, right?
Hmm, hmm, hmm,
You
hmm, hmm.
understand? There are two different roles. One is you are uploading a document. That is a different role that you have. You are not the same person who is asking the question in an enterprise generally, right? Your team is coming up and asking the question.
Agree.
When they are asking the question, they must have the latest information.
Okay. Now,
When did we have that latest information? You went ahead and uploaded a file today.
hmm,
After 1 hour, someone come and ask the question. But do we have that information in the vector DB or vector index? Perhaps not. So this pipeline will make sure that as soon as you upload something, there are different connectors that you can use to make sure you pick up the change, you process the data, you
hmm.
convert it into chunks, you push it into the vector DB. Because the user who is coming and asking the question is not asking the question on SharePoint. The retrieval is happening from VectorDB. So the information have to be available in VectorDB.
Correct. So the question comes, it again, of course, to read to the embedding vector DB, you need to use the same embedding model. So query comes, it goes to the embedding model, it converts. So when it converts that query, it goes into LLM and converts into the vector language. It become a prompt, right? If I'm not wrong, it become a
Okay, so I mean, think of it like, let's say we are asking a question to GPT-4 right now, and
yeah.
I tell it, hey, what are the specific um, HR policies related to traveling in Petronas? Let's say
Hmm.
you're from Petronas, right? Will the native GPT would know this? Perhaps not, right? Why doesn't it know? You just ask this question and it doesn't know, right? It would either say, sorry, I don't have this information, or it will start telling you general HR policy, right? Which is not really interesting for you.
Hmm.
But what if with this question, you would have given it in a paragraph somewhere down within your question, below that you say, hey, here is the information that I'm giving you. The answer is somewhere here. Will then ChatGPT be able to answer you? The question is yes, because you gave it a question and you also gave it the context. In this scenario, we don't have the context, right? So where is the context? The context is sitting somewhere in your vector DB. So
Hmm.
when you ask the question, we have to find those paragraphs where this information may be hidden. which means doing a search, a semantic search, right? We haven't it gone there. I have some slides that talk about hybrid search, semantic search. But at this point in time, let's make it very simple. You ask a question, we found the context which is in the vector DB somewhere.
So, so
We now have that.
sorry, yeah. Sorry, yeah. So when you ask a question, it goes and retrieve and then put it into the prompt, is it?
Exactly. This
Ah,
is what is happening.
okay. So it means the question should go to retrieve and retrieve should go to prompt. Why this question is directly connecting to prompt?
Um, uh, it is also connected here, right? So
Both
you did
places.
retrieval,
It
you
goes.
got the chunks, you
Okay.
got the chunks are going here, and the questions also going here. So now you have the
Both,
question
both
and
are.
you have the context. Both of them are going to the LLM, right?
Okay. Makes sense.
This is
So
RAG
are
for
you,
you,
so
right?
are we saying that, sorry?
This is RAG for you, and this
Yeah.
is
So
basic
are we
RAG.
saying that, so again, 2 minutes left. Are we saying that LLM is right at the end? LLM is not there in the start.
No, it is not there.
Okay. But where is NLP then? Because then you ask a question is in a very natural language thingy, right? But it needs.
Exactly. That's where this vector match comes in. That's the whole beauty of this vector search. Remember, we use an embedding model to
Yes.
embed something, this model
Hmm.
that converted it into this vector. This is where NLP is.
An NLP is a generic NLP, or actually, this is the question for our. So we will start in our next session on this one because this is. I'm not going to let you go. So because this is NLP thingy is becoming a big issue because general NLP is everybody provides, right? But you have to train. Correct me if I'm wrong. You have to train your NLP or mature your NLP based on your domain. I'm sitting in oil and gas, you are sitting in financial sector, someone is sitting in fintech, someone is sitting in banking and telco, right? So correct me if I'm wrong, that we have to train or build that or mature that NLP based on your domain. Is that correct?
No, that's absolutely correct. But what I really want to, highlight is NLP is also everything that is happening in LLM, right? Because again, what NLP is, I believe we are not really talking about neuro linguistic programming. What we are talking about is natural language processing right now.
Yes.
And when you say this NLP, what LLM is doing as you are sending it information, just when you go to ChatGPT application and you ask a question, or Gemini or Copilot or wherever, all
Mm-hmm.
of that is NLP, right? That is also considered NLP. But
Yes.
here, what we are talking about is it will definitely help if you have an embedding model, not the GPT model,
Mm.
not that transformer model, but maybe a cross encoder here or this embedding model here, which is converting your text into these numbers. If that is trained on your specific data, it will have better embeddings. And then later on, you will be able to do the better match here when you're asking questions, right? So
Okay.
that will definitely help. That
Okay.
is something that is advised again when you're working on a very specific industry.
Awesome. I do not want, see, the whole part of, just to take a couple of more minutes, the whole idea of this data podcast was, that's why we call it, let's talk about data. It's about not sales pitch, not pre-sales pitch. I really want
Yeah.
to create podcasts which really tells you what we are doing actually. I don't want to be
Yeah.
a traditional podcaster, right? I am talking to people like you. I'm challenging you, right? I have stopped you at many times to ask you, hey, don't
Yeah.
go through. I don't understand. Make me understand. So that is what I want to go into this niche area, understanding from different people. Does that make sense to you?
Yeah. Sure. Definitely.
Okay. Okay, Vakas, thank you so much. Pleasure. Thanks for taking our time. I will bug you again.
Yeah, sure. Thank you. Thank you again for inviting me. Take
Take care.
care. Have a good day.
You too. Bye bye.